Hello, this video is to go with section 1.3 summer video. We're looking here at continuity, and we want to determine if this function is continuous at the given point. To do that, we're going to use the continuity test. And the continuity test looks at the limit as x approaches the value, which in this case is 5, from the left and from the right, and then looks at the function value at that point. If those three things are all the same, then the function is continuous. So let's take a look at that. We want to look at the limit as x approaches 5. We'll look from the left first, of x squared minus 25 over x plus 5. So to look at this limit, we're going to look at it numerically. And so we're going to go to our graphing calculator and put this into our graphing calculator and make a table from it. So here I have entered the equation that we want to work with into the y equals on my calculator. And then I want to go to table set and set the independent on ask and leave the dependent on auto. And then go to table. And remember that we want values that are close to the number in question. The number in question is 5. We're coming in from the left. So I'm going to go ahead and put in numbers like 4.9. And I get negative 0.1. Then I'm going to get closer to 5 coming in from the left still. So I'm going to do 4.99 and maybe 4.999. Okay, so it would appear that this is getting close to 0 as we come in from the left. While we're here, let's look at coming in from the right also. So I'm going to kind of just go through and look at things close to 5 from the right side, like 5.1, 5.01, and 5.001. So it would appear that this function is getting close to 0 as we get an x value close to 5. So if we go back now, and we're going to say, okay, this limit appears to be 0, and the limit as x approaches 5 from the right of this function appears to be 0. Now we need to look at, well, what is h of 5? First of all, does it exist? And if so, what's its value? And if we just directly substitute a 5 in for x there, we get 25 minus 25 for the numerator, or 0 for the numerator, and the denominator, 5 plus 5 is 10, which is 0. So because these all exist, and they are all the same value, we determined this function is continuous at the value in question of x equals 5. Had these not been equal, or if the h of 5 did not exist, then we would say there is a discontinuity, and we would try to determine, well, what type of discontinuity is that? Remember, the three types are the removable discontinuity, the jump discontinuity, and the infinite discontinuity. And your table is going to help you determine all of those. So that should help you out with questions 1 through 4 on the worksheet for section 1.3.